Okay, so in this video, I'll be discussing when you're doing a face portrait, how do you know whether you have to draw it clockwise or anti-clockwise? So I'll start with the basic revision of what we did in the last video, in which understanding the nature of the eigenvalues. So let me consider only complex roots in this video. Now, if you have complex roots as the eigenvalues, there can be three possibilities. You can have the real part being positive. These are complex roots with real part being positive. There's complex roots with real part being negative. And this is purely binary, when the real part is 0. When the real parts are positive, when the roots are complex, the real parts are positive, you will get an unstable spiral. Means when the real parts are positive, the solutions will spiral out. Now it can spiral out either clockwise or it can spiral out anti-clockwise. Okay, fine. So now how do you know whether it's going clockwise or anti-clockwise? I'll be explaining you further in this video, so please hang on. If it's purely binary, you get equilibrium at the center, and again you have to draw ellipses of this sort. Either it will go clockwise or it will go anti-clockwise. How do you decide that? So I've shown you that with a couple of examples. If the eigenvalues are complex and the real part is negative, they spiral in. So stable spiral, they'll spiral in. Means in long term, dx by dt and dy by dt will approach 0. That's what it means. So it's a stable spiral. So if you're looking at population, the population of the two species will become 0 as time elapses. So that's what the whole logic is. Now, how do you decide whether it's clockwise or anti-clockwise? This is exactly what I'll be explaining you. Just looking at the eigen vectors or eigenvalues, we cannot say that. We have to know the equation as well. That's what the motive of this video is. So let me start with the explanation. There's a sum that I've taken from Hayes Mathematics. The system dx by dt, x dot is dx by dt, is minus x minus 5y, dy by dt is 2x plus y, can be written in the matrix form x dot is equal to ax. So this can be written in this form, where your matrix A is the coefficients minus 1, minus 5, 2, 1. Now this is useful when you're finding your eigenvalues, but the eigenvalues in this sum are given. The eigenvalues are plus or minus 3i. I'm assuming you know how to find the eigenvalues from this. If not, then refer to my earlier videos. Explain why the equilibrium point is at the center. Now you look at the nature of the eigenvalues. Since these are purely binary, you have the second case. When they are purely binary, the equilibrium is the center, and this is the shape that you get. So looking at the nature of the roots, we can tell that whether it's A, B or C. So in this case, it's clearly B. But now how do you decide the sense of rotation? To decide the sense of rotation, you need to consider any point. So in this sum they've given you, find a trajectory at point 1, 0. Means after 1, 0, how does the point move? That's what we are supposed to find out. Trajectory is the path of the population, or the point, you can see. So if I put 1, 0, so in place of x I'll put 1. In place of x I'll put 1. In place of y I'll put 0. Here I'll put 1 and here I'll put 0. So if I do that, I'll get minus 1. Dx by dt is minus 1 and dy by dt is 2. This is what I get. Now what does minus 1 mean? Minus 1 mean is my initial point is here at 1, 0. Minus 1 means as your time is increasing, your x is decreasing. Means this will move on the left. Xwards you are moving on the left. Correct? And dy by dt is positive, means as your time increases, your y is increasing. So that means the second point will be here. So if you see that my trajectory from this point is coming this point, means obviously I'm going in an anti-clockwise direction. Okay, so overall the next point is on the left and above. So that means my spiral is this way. Means the solution is spiraling anti-clockwise. Now with the software this becomes very easy. Obviously you don't have the software when you're sitting in the paper. So draw the phase portrait, you type in the equation. This is the equation, this is the equation I've typed in this. So you draw the phase portrait, it draws it. Now you solve. So that means if you start from 1 comma 0 is here somewhere. So 1.5 is here. So if I solve it, so this is where it's giving you. So this is how your phase portrait is. Correct? So similarly, if this is point is 6 comma 0, so if I'll get a trajectory. And I know it's going anti-clockwise because with every subsequent point it will go to the right, it will go to the left and up. So it will go left up, left up, left up. So that's how. So you take that point and you just substitute, you'll get it. Okay. So this is what you need to remember. You need to put in a particular point. Now let me just explain this with a spiral as well. So again, I've taken an example over here. Consider the system dx by dt as minus 5x plus 7y, dy by dt is minus 2x plus y. The initial point has been given. Find the eigenvalues. I'm not wasting time in finding the eigenvalues. Refer to the earlier video. If you see it's negative, so negative means it's a stable population spiraling in. It will spiral in. Now we need to decide whether it's going clockwise or anti-clockwise. For that, you substitute any value. So I'll put in the initial value. Correct? Find a trajectory. So I'll find a trajectory at any time at t is equal to 0. So initial point is 0,3. So I put in 0, 3. I'll put in 0, 3. So if I put in 0 over here and 3 over here, 7 3s are 21. I put 0 and 3 over here. That's 3. That means, what does this mean? It simply means that as time elapses, your next x will be on the right and your next y will be up. So if you start from, my initial point was 0, 3 here. So 0, 3 is a point. My next is on the right and up. So that means from here I'm going here. And I know overall this has to spiral in. So therefore this will spiral how? Clockwise. Clockwise it will spiral in. So that's what you need to do. So looking at the solutions, you may not be able to do it. So if I use the software over here, it will tell me what exactly happened. Let me show you that as well. So if I do it over here, so if I enter this as, I'll clear graph, okay, and I'll put this as minus 5x plus 7y. And if I put this as minus 2x plus y, and my initial point is 0, 3. Correct? Yeah, so this is the same. So I'll draw the phase portrait. This is a phase portrait. You get it automatically in the software. Okay. Now solve. So 0, 3. So 0, 3 is somewhere over here. So if I just solve it, so this is how it's spiraling in. It's spiraling in. So it can be any point here also. So suppose if I take a point here, so you can see that it's going this way and spiraling in. You can, so this is, so any initial point will be given. It will always go, as we said, it is always going clockwise in this case. So you can take any test value. You can start from any random point also here. Correct? So if you are doing with population, your x and y would be positive. So they might give you some point, and depending on where the point is, so if the point is here, the population will spiral in. Correct? And it is going how? It's going clockwise. So to understand clockwise and anti-clockwise, you will have to substitute the values. There's no way out. I hope you understood this video clearly. Thank you.